we're talking about transformations of quadratic functions in standard form, and we want to graph quadratic functions in standard form. Determine whether the graph has a minimum value or maximum value from the a value. In order to do that, the first thing, well, just by looking at the a value, a value is negative. So when we're talking about this graph, we're working with g of x, which is represented on the left over here. So g of x is this graph right here. And the first thing we want to do is calculate the equation for the line of symmetry. And the way that we do that is we can say x is equal to negative b over 2a. So I'm going to write that equation down right here. And we're going to say x is equal to negative. Okay, that is stuff that is always constant. That's stuff written in black. The thing that's going to change is the b value is going to change, and the a value is going to change. Everything else is going to stay the same for this equation. So this is in standard form, and we have to identify a, b, and c. So a is a quadratic term. It's the coefficient in front of the x squared. So a is equal to negative 2. B is the linear term. That's the term in front of just the x variable. So that is equal to negative 4. And I forgot my negative sign here. Got to include that negative sign. And C is the constant term, which is out here by itself. Now, the thing that C helps us with is C identifies our y-intercept. So right here at 0,5, that's our y-intercept. That is where the graph is going to intersect the y-axis right there at 0,5. Now we can substitute these values into the equation over here. So the x is going to stay the same. The negative we always have to keep there. We're going to plug in the b value. The 2 is going to stay the same. And then we're going to substitute in the a value as well. So the b value is negative 4. And the c value, or excuse me, the b value is negative 4. The a value is negative 2. So we can do this math. Negative times a negative is a positive. And 2 times negative 2, that's negative 4. And so we get x equals negative 1. And that is the line of symmetry. X equals negative 1. And that is the line right here that goes through, that cuts the graph into 2 halves. Okay, that was g of x, which is right here. And now we're going to work on f of x. So f of x is this graph down here, and that's represented on the right. So we're going to follow the same process that we did before. We want to use the same equation, and that equation is always going to be the same when we're trying to calculate the line of symmetry. So we're going to have x equals negative over 2, and the b and the a are the things that are going to change. So the b is in the numerator and the a is in the denominator. Everything else is going to stay the same. Well, in order for us to substitute the values in, we have to identify them from the equation. So the lead coefficient, or the coefficient on the x squared term, is 2. So a is equal to 2. B is equal to negative 4. And C is equal to negative 2. And again, the C value helps us out with our y-intercept. So right here, our graph crosses the y-axis at 0, negative 2. And now we can substitute our values into there, into the equation. So the thing that stays the same, x equals, we're always going to have that negative, and we're always going to have that 2 in the denominator. Those things are never going to change. And then the only thing that changes is we're going to substitute in our b value, which in this case is -4, and our a value, which is 2. So we can do this math. We get x is equal to 4. Negative times negative is positive, so that's 4. And 2 times 2 is 4. So 4 divided by 4, we get x is equal to 1. And that is the equation right here that we have for this line of symmetry, where we have x is equal to 1. We can take a look and we can see that we have the graph here, and we've calculated our y-intercept, and we've also have our line drawn for our line of symmetry. So those are 2 points that we've calculated so far. We've also done the same thing for f of x, which is right here. Again, we have our y-intercept, and then we have our line of symmetry, which is at x equals 1.